How to calibrate your Galvo using RE4. To access the calibration page, open your preferred browser and enter the IP address in the address bar. Today, we'll cover the Xy2 calibrations, including the Xy2 calibration, Xy2 calibration, and calibration management. First, open the Xy2 calibration. The instructions indicate that the first step is to home the laser head, so let's do that now. Once the laser head has finished homing, the next step is to determine the lens's perfect focus to the base plate. This is typically pre-marked on the Z stage during our quality control process at the factory, with color-coded lines on your tower indicating the specific distance. Once the laser has finished homing, let's go ahead and use our touchscreen to jog our laser down to our desired focus. Now that we've set the desired focus distance, place a black aluminum business card under the laser dot. Run a focus test to ensure accuracy throughout the process. We can run the focus test by visiting our machine's current server. Currently, I am using RE4B. Select the Laser Focus Test button. In this example, I'm using a 200-watt MOPA laser, so my settings may differ from yours. However, the goal is to run this test at low power to ensure accuracy. I've set the increment to 1 mm, so each time the laser pulses, the head moves by 1 mm through the focal range. This test can be run multiple times, and the increment can be adjusted to a smaller value for increased accuracy if needed. Once the job starts, the laser will move upward in 1 mm increments, creating a grid-like pattern. After the job is complete, we will examine the card under a microscope to gain a clearer understanding of the results. Let's take a look under the microscope. The laser engraves the squares in a snake-like pattern, separated by the 1 mm increment we set earlier. Initially, the engravings may appear blurry, but as the laser reaches squares A5 through G5, distinct straight lines become visible within the boxes, unlike the blended appearance of the others. What we're looking for is where the laser first starts engraving these lines and where it stops. In this case, my selection would be A5 and G5, and the system will automatically select the midpoint between these values. Alternatively, you can manually choose the box where the lines are most clearly defined. In this example, I would select D5. We can make our selections now and hit the Focus Selected Result button. Now that our laser is in perfect focus to the base plate, let's jump back over to our calibration page. We are now ready to begin the overview of Xy2 board calibration. At this time, please set up your Xy2 board within your workspace. The objective of this setup is to ensure the board lies completely flat and is fully visible to the camera. If necessary, take a moment to adjust your camera to achieve a clear view of the entire board. Once you are ready, select Start. The laser will move and capture multiple pictures at different heights for this board. We can follow the calibration stages at the bottom of our screen. The laser is now generating the intrinsics for this Xy2 board. The calibration process is now complete. Please review the results carefully to ensure there are no blank areas that the camera failed to detect. If you notice any blank spots, these may be caused by a damaged Xy2 board or excessive light shining on that area. Once you are ready, select the next button to move on to the next step. In this step, it is suggested to use fluorescent paper in the workspace. However, since I am using a high-powered MOPA laser today, regular white paper should suffice. For those using an ultraviolet laser, consider using neon colors like orange to help the camera detect the dot more effectively. The dot brightness setting controls how visible the dot is to the camera. Adjusting this setting may not provide any immediate visual confirmation, but rest assured, it is working as intended. Since I am using a 200-watt laser today, I will set the dot brightness to 25. Select Start when you are ready. During this step, the laser will scan the workspace while the camera records all available DAC values. Be sure to keep the dot on the paper throughout the entire process to ensure accurate results. This step is now complete. Review the results to ensure all dots are correctly positioned. If necessary, you can reduce the dot brightness and repeat the calibration process until the results meet your expectations. The calibration is now complete. You can stop here and return to your workspace to begin engraving. However, if you like to achieve even greater precision, stick around as we dive into the next step, Xy2 calibration. In this phase, we'll focus on making finer adjustments to ensure absolute accuracy. Each calibration begins the same way, and since we've already completed this earlier, you can simply proceed by clicking Next. The first step is to adjust the laser to focus on your test material. Since I'm using paper today, I'll leave the material height set to 0, as it adds virtually no thickness to the base plate. The next step is to engrave the Xy2 board. If you don't have a scanner, proceed with engraving the DAC Vector Xy2. However, if you do have a scanner, engrave both the DAC Vector Xy2 and the DAC Vector Xy2 4x4, as both will be needed in future steps. Select the Job Run Page button. Since I'm using a MOPA laser today, I'll select the MOPA DAC job. Next, adjust your settings to match the material you've chosen for this test. After adjusting your settings, click the Set button and proceed to run the job. The laser will now engrave the Xy2 board. The goal is to ensure all squares fit within your material. While some engravings or lenses may appear clearer than others, it's sufficient for the camera to detect the majority of the squares. If a few squares are missing, don't worry. This can be adjusted later. Once the engraving is complete, return to the calibration page to proceed with the next steps. The next step is to scan the Xy2 board. Start with a threshold setting of 100. If needed, you can lower the threshold and scan again to capture as many corners of the Xy2 board as possible. In this capture, we can see that most of the corners have been detected, but the left side and top are still missing. Let's lower the threshold and attempt another scan to detect at least a few corners in those areas. In this image, we can observe that the camera successfully detected a few additional corners in the bottom left area. Let's lower the threshold to 1 and see if we can capture a few more corners. It seems we're getting the same results, so we'll proceed with using this image for refinement. Next, navigate to Step D and select Generate to review what the camera has detected. Here we can see that the camera had difficulty detecting some dots in the left column, and the entire top row is missing. This isn't a problem, as we'll be able to manually add these dots in the next steps. We can also observe in the original image that no dots were generated in these areas either. Here we can see that the blue areas correspond to the points missing in our scan. Since the camera already ignores the outermost edges, we only need it to detect the inner square highlighted in red. We're now ready to manually input these points. Start by selecting the Edit SVG button. To determine the values needed for the left column, we can identify a pattern by examining any existing point in that column. Notably, the y-axis DAC value for the last point in this column always ends with 4096. With this information, we already know the ending number. Next, we need to figure out the starting number. To do this, simply copy the coordinates of a neighboring point and adjust its position to the missing areas. Then, change the last number in the y-axis value to 4096. This method allows us to accurately input the missing points. I will do this for my system now. In the meantime, reference this chart to get a better understanding of how these DAC values are depicted in the system. You can figure out what dots you are missing in your scan and use this chart to replace the values in your system. Once you've added all the missing points, click the Save SVG button to finalize your changes. Next, return to the calibration page and upload the refinement file by selecting Upload Refinement. After the upload is complete, click Generate under Generate New Calibration. You can now review the updated results and confirm that all previously missing points are correctly placed. If you don't own or have access to a scanner, the calibration process is now fully complete, and you can return to the workspace to start running jobs. However, if you do have a scanner, stay with us as we complete the final steps. Let's dive in. Head back to the Job Run page, as we'll now need to run the 4x4 Xy2 board. Make sure to adjust your settings for the material you're using. If you're working with thicker materials for this test, ensure that your laser is set to the correct height for proper focus. Once the engraving is complete, you should have a Xy2 board similar to the one shown here. Ensure that the board is engraved clearly for accurate results. Today, I'm using plain white paper with a black square printed over the entire sheet, simply removing the ink during engraving. This method works well for both fiber and ultraviolet lasers. Once the engraving is complete, return to the calibration page and proceed to Step 2 of the Xy2 calibration. Next, use the camera to scan the Xy2 board and ensure that all dots are correctly identified. Here, we can see that all dots have been correctly identified, so no corrections are needed. Next, select Generate under Generate New Calibration to proceed. We may view the results and ensure once again all dots are correctly identified in the workspace. Select Next. We are now ready to scan the Xy2 board using a scanner. If you've already completed the engraving earlier in this video, there's no need to rerun the job. Simply take your engraved Xy2 board to your scanner and scan it at a resolution of at least 300 dpi. For this demonstration, I scan my engraving at 600 dpi for improved accuracy, so I will keep 600 as my default scanner resolution. Next, upload the scanned image and select Scan Xy2 Image. Ensure that the orientation of your scanned image matches the orientation in which the Xy2 board was originally engraved. Once the scan is complete, go to the Results tab and ensure that all dots are correctly identified. If any adjustments or refinements are needed, you can make them now. We can see that almost all of the dots were correctly identified using the scanner, so no adjustments are needed on my end. We can now proceed to generate the new calibration with these results. In the results, we can see that the calibration successfully matched the 4x4 engraving we did earlier, highlighted in green, with the scanned image of the large Truco board. This is a positive sign that the calibration is complete and accurate. We can now select Calibration Management and download the successful calibration for this specific lens. This calibration can be imported later if you ever decide to switch lenses for different applications. The calibration is now complete. You can return to your workspace and begin running your jobs as normal. I hope this video helps out, and thank you for visiting Full Spectrum Laser. Until next time, keep on making.